Hey guys, this is Wanderson from MATLAB VFX here. You can download this entire project for free at Gumroad. The link is in the description. In this course, I'm gonna build a full procedural Rubik Cube inside Houdini from scratch. You'll learn how to model, structure the logic for cube rotation, and prepare the asset for animation and the structure effects. Whether you're a beginner exploring procedural modeling, or an intermediate artist looking for deepening your Houdini skills, this is a great project to expand your technical and creative abilities. Let's get started. Let's create first a subnet. Let's rename to Rubik Cube. Change the color. Let's dive inside. Create our first geometry node. Rename to Cube Geometry. And now we are going to create our cube tool. Create a subnet. Rename the subnet to Rubiks solver. Let's create a digital asset here. Change the path to heap ADA directory. First, let's create inside this subnet here the structure of our Rubik's Cube. First, we need to create a cube, a box. Let's change the size here to 0.5 in all of 3 axes. Let's create a transform and rename to scale down. Change here in the uniform scale like 0.98. Create a poly bevel. Change the bevel like distance 0.033. Round in 4 divisions. Enable these groups here, point fillet polygons and edge fillet polygons. Create a delete. Rename to delete bevel edges. Just keep this face here. Create a vex for change the color of the primitives. Rename the vex to vex color faces. The script here is just pretty simple. We need to change each face of the primitives for the respective colors of the Rubik's Cube. That's the color representation for the cube. Let's change here each face. For example, if I create the top color of blue, we need to create another face respective orientation with the same color here. Let's create ID color equal at prenum if at prenum equals 0. Let's change the color to CHV color 1 and create a group to E at group color green equals 1. Change the color here, the type color, and duplicate the 6 parameters here. Just press D and duplicate here 1, 2, 3, 4, 5, 6. Apply, change the color number. The first color should be green at this side here. Just copy these lines here and change the color. Second, 30, 40, 50, and 60. Change the primitive num value here to 1, 2, 3, 4, 5. Change here to the colors parameters 1, 2, 3, 4, 5, 6. The second color should be blue. Change it here to blue. The third color should be white. At the top, yellow. red, and final orange. Red here, and orange here. That's the colors. Let's see the diagram. If the colors white is top, the respective color at the bottom should be white, yellow. At the side of the white should be red, blue, and orange in their respective order, which is correct. Create a poly extrude. Change here the distance to 0.202. Create output back and enable this back group here. Create another poly extrude. Change here the group to extrude back with the same distance 0.02. Just to fill the edges, the back. Change the camera here, the first one, to avoid the clipping. Let's merge this. With the structure, change the color to different color like black. Like dark gray. Here, let's fuse the points. Labs dissolve flat edges. Just to dissolve these middle edges here, we don't need that. And create a group. This group should be face colors. Another group here should be group inner structure. Let's copy the segment to a box to move this at the side. Create a box. We just need the points. The division should be 3 by 3 in 3 axes. Let's copy 2 points. Like this, and create a VFX attribute here for respective point num. Should be EID E at piece ID equals at ptnum. Just to work in the solver, the rotation solver, we need that parameter here, that attribute, VFX piece ID. Now we need to remove, let's see, and explode the view. We need to remove these face colors here between the inner structure. We don't need these face colors inside. We just need the outside colors for ET cube. Create assemble. Create a packed primitive and transfer this group here, group face colors. Let's split. Split by group face colors, invert selection, and merge. Here we need to create the bound. We don't need the exploded view. Create the bound. Okay. Create a transform. Just to scale down. We are going to use this box here to make the groups inside of the inside face and delete them. Like 0.9. Let's create a group from the second input of the split here. Rename to inside face. Change here to points. Disable the base group. Enable the keep in bounded regions and change it to bound object. Create a blast. Blast inside face. And merge and change the group here to group inside. Here you can see that we are remove the inside face. We don't need the entire inside face, just the outside. Okay. The base structure of the cube is created. Now let's solve the rotations. First, let's create unpack here. Transfer all the groups. For create that, we need to create a solver. Change the name to solver rotations. Before I dive in the solver, let's adjust the geometry here to make more polished geometry. We need to make a switch. Let's disable the solver, switch, polish, geometry, switch, polish, just to bevel the color face because it's too square. I want to bevel this face too. Create a poly bevel. After these rotations, poly bevel. Just the face colors, like distance 0.02, round of 3, just like that. Let's see if it's smooth. Okay, let's fuse and subdivide. The subdivision should be used in rendering. Okay, it's working nicely. Using that auto node here. And create another switch to flip the animations. Because the solver itself doesn't solve the Rubiks, we need to flip the animation to a scramble position to the final position, just to make the illusion of the solver. Because here in the solver rotations, we just solve the rotations. We don't solve how solve the Rubik's Cube from any states. We are just solving the rotation for each axis here, in the 3 axes, for all the faces. Change the switch here to switch, reverse animation. Create a time warp. In the time warp, we need to create here feature range. We need to input range here should be $F start. The second value should be $F end. And the output frame range should be the inverted. First value should be $F end. And the second value here should be $F start. That's it. Now we can solve the rotations here in the solver. Let's dive inside. Here, we just need one simple VFX script. Pointer angle, rename to VFX rotations. We don't need any of these inputs here. We need to create some parameters here. To avoid typing each line, I will copy line by line and explain what is happening inside the script to understand why we need this line to solve the rotation of the cube. The first line should be this. For each time step, for each frame, we need to increment the angle of the rotations, for example, the top. For example, just one frame, we need to rotation like 6 degrees, another 6 degrees, and that's all. But the angle increment here should be 10. Let's copy these other lines here. This is just to invert the angle of the rotation. If you need to invert the angle increment should be negative multiplied by -1. This should be a toggle. And put this up there. Now we need to create toggles, 6 toggles to enable the rotations for each face. For example, a first toggle should be enable top. If these toggles enable, just the top face will rotate for each frame increment here. Let's do that just for the enable top and disable the other toggles here, just to understand what is happening in the solver. We need another attribute here, offset. This offset should be considering the side position of the cube. The offset should be the position here, the between position of these cubes, where I will find this top face to rotation here. I think this should be around 0.25 here. 0.25 maybe. .25 the offset. And create more 3 attributes here, just for the angle directions. If you are going to rotate the up direction, we need to set the vector for each rotation here. For example, when I rotate the face, the white face and the yellow face, we are going to rotate in the y-axis. The red and orange should be rotating the axis, and the blue and the green should be rotating the z-axis. Let's view with this information here. Direction up should be 0, 1, 0. Direction front should be 1, 0, 0. And direction side should be 0, 0, 1. This is the vector we are going to rotate each face. Now we need to change it here to detail. And here we need to put a line. For each point we are going to search. We are going to search the near point for each vectors and it set this for rotations. For int pt equals 0, pt less than any points 0, pt increment by 1. Let's grab the position of our point, vector position equals point 0, we need to position for each point. Now we select the face, top face, let's move down here. Top face should be, if this enable top is active, we are going to rotate that. We need to check the position, if position .y greater than offset, this value here, 0.25. Create a matrix. We are going to use a matrix to make the rotations for each face. Matrix M equals identity matrix. rotate the matrix by angle increment, which should be 10 degrees per frame. Increment by the direction up. Now we multiply the position by the matrix, the rotation matrix, and set the position back to the point. Set point attribute should be 0. We need the position for the PT number, defining the position with the set, just to change the position of the point itself. Let's see if it's working, just for the top layer, the top face. Let's fix the errors here. Enable top should be a toggle. Let's see the error. Unexpected editor file. This bracket here. Okay. Let's go up there and see if the rotation is working. We need to create the enable rotation here, enable top. The rotation of the top is working. Now we need to make all the same code here for each face. Let's enable all these other face here. Populate with the attributes. We need to change this enable here to toggles, all the enables. Let's move this down and change this to toggles. Enable bottom to enable right to toggles instead of integers. Okay? This inverted angle should be a toggle too. Let's copy the same code here and change a little bit. Change it here to bottom face. We need to change the position Y to equals negative offset. Direction up should be negative. Okay. Now for the front face, the position should be X instead of Y. Angle increment, okay. Direction front. Minus direction. Actually, just direction. Copy the same snippet code. This should be back face. Just change here the X to minus negative offset and direction should be negative. And the last two should be left face and right face. Left face. Actually, we need to change here. Enable top to enable bottom. Enable front. Enable back. Now enable left face. Left. This direction should be side. With the Z. Copy the last one, should be the right. Right face. Change here to right. Position Z minus negative offset. Direction should be minus direction side. Okay. Let's see if all the rotation is working. Top is working. Let's see the bottom. The bottom is working. If we invert the angle, okay. The front. inverted angle is working. The back angle is working. Inverted angle is working too. The left, let's go back to the beginning. Back left is working, inverted angle, okay. And the final is right. The right face is working, inverted angle is working. All the rotation is working. Now let's go back to the solver rotation here. We need to promote these parameters here inside the VFX rotation node to this solver here. We just need here. To promote enable top, enable bottom, enable front, enable back, left and right. Here we are going to just control these attributes here to make the rotations. Now let's organize the Rubik's solver here, 88. Change the color. Let's change the type of parameters. We don't need the maximum inputs. We just need to create some parameters here. We need to create a toggle. Let's create a folder first. This should be high res geometry. Just a toggle. Create another toggle just for reverse animation. Let's call it the reverse animation. Let's create a button here. Create a separator. This button should be delete. Delete keyframes. Because for the manipulate the cube, we are not going to side and click for each toggle here. We are going to create this procedurally using Python at the AG8 level here. Like in the original here, we can see we just click these buttons here, minus and plus, to create the faster rotations. We are not going to animate by here. We are going to animate by clicking this button, which is pretty fast. Let's configure that. Create a label. Create another. Actually, we need to move this up. Create another separator here. Change the label here to rotation controls. And create all the buttons we need to apply the rotations to the Rubik's Cube. This should be top. Rotate top minus. Let's call it the label top minus. Duplicate. We need to change here the top minus to horizontally join the next parameter, just to join the parameter here. Instead of just one button per line, we are going to make a group for each face minus and plus. Top minus, top plus. Okay, just duplicate for all the face. 1, 2, 3, 4, 5, 6. And rename that. Rotate bottom minus, bottom minus. Let's speed up the process here in the video. That's it. We created that. We need to create two. We need to promote this toggle attribute here to the tool interface here, just to control in the Python, because we're not going to change the toggle directly. We are not going to change the toggle directly, just the buttons, but we need to, this attribute should be created the tool level to control with the Python. Let's save the tool. Let's go inside and promote each parameter here. Export parameter to the type properties for each one. And the parameters appears here. Let's create a separator and move it for inside the folder. Change the folder name to parameters. Okay. Now for creating the Python script for control the points. Actually, we need to copy this parameter here to control the high resolution, which is that parameter here. And the reverse animation. Copy parameters, go inside, copy to the switch here. The first parameter is working, high resolution geometry, and the reverse animation. Let's go to Ink Script tab here. Create a Python module. Apply. Let's write some Python script here. The first function should be for delete keyframes. After, for example, create animation here, if you are needed to delete keyframes, we don't need to delete all the keyframes here. Just by left side, delete key channels. We don't need to do that. We just need to click delete channels, delete keyframes, and now this keyframe should be deleted. Delete keyframes, cowards, node equals cowards. This cowards node should be, you'll be capture all the attributes, all these toggles here, and delete the channels by that. Node, if node params to reset equals, we're going to put the name of each toggle here, enable, top, separate by column, 3, 4, 5, 6. Enable bottom, enable left, enable right, enable front and back. Now for each param name, in params to reset, param equals node.param to get the parameter name here. If the param exists, we are going to delete all keyframes and set the value to disable to 0. The disable value should be 0. Let's copy the function name here and apply to the button. To do that, we're going to select the button, and the callback script should be Python here, and you are going to put whole.phm brackets dot delete keyframes open brackets cowards. Let's see if it's working. For example, let's create some keyframes here. Delete keyframes, always working. Let's put all, enable keyframes, delete keyframes. All these parameters work. The delete keyframe is working right now. We just need to configure the top, these face rotations here. First, we're going just to use the top minus and plus to see if it's working. Let's save the node type. Let's go back to the script, create another function just for rotations. Let's rename the function to, let's create few lines here, rotate face, cowards, face ID should be the color, the names here, top, bottom, front, back, left, and the direction, if you are going to reverse animation or not. Self node equals cowards, just to get the AG8 node itself, node, current frame equals who.frame, to get the frame number here is use this function here. Switches, okay, equals the name of the face. Just a list, top, bottom, front, back, left, right, inverted, invert, param equals self node dot param. The name of here, this parameter is a reverse animation. Actually, it's not the reverse animation, it's a parameter we need to create here. I forgot that. Let's dive inside the solver rotations. We need to promote this parameter here. Export parameter to the type properties. This parameter should be appears here, but don't need to be visible in the interface here. We can just make invisible, but we know the name. Inverted angle in the script here. Invert angle or inverted angle. Invert angle, okay. Now let's set some frames equals a list which contains the current frame plus 1, current frame plus 9, and current frame plus 10. Because, for example, when I click the top minus or plus, we are going to set keyframe that current frame at the current frame plus 1, 9 frames later, and 10 frames later, just to make the rotation duration around 10 frames for each face. Here, we need to see if direction equals negative. We need to create some values here just to animate the invert angle here. Let's show the invert angle to see what is happening when I set the keyframe. Okay, values should be equals a list of 0, 0, 0, 0, because when the inverted angle is actually we need 0, 1, 1, 0. When the inverted angle is enabled, we need to set this keyframe 0, 1, 1, 0 at the keyframes. When the keyframe is disabled, we need to change all the values to 0. For F, we're gonna val in zip frames values whole.set frame, create a frame key equals whole.keyframe lowercase f key dot set value val invert param here dot set keyframe the keyframe itself. Copy here the direction, just a plus direction. The plus should be all the 0 with the same code here. Now we are going to apply the keyframes for the rotations itself. For switch, in switches, param name. Let's give some space here to the script. Let's save the file and save the tool. Param name equals enable underline plus switch param equals self node dot param name. If param exists, if param is not exist, just continue to another face. If switch equals face ID, which should be the name, these names here, top, bottom, front, face, front, back, left, and right, we set the values of the keyframe equals 0, 0, 1, 1, 0. Else, all the values should be 0. And set the keyframe itself here. For F, val in zip, frames values, whole.set frame, key equals whole.keyframe, key.set value, the val is set the frame itself. Set keyframe lowercase f, the key. Let's save this. How can I apply this function to behavior for each click? We need to copy the rotation face here. Let's go, for example, the top face. Top rotation, we need to put a callback here. row.phm dot rotate face, put call args, the top, and then minus. Copy all this here and apply to the plus. Now let's see if it's working here. Let's move this. Let's just the top. We have an error here. Let's see what is happening. Enable top. I forgot the switch here. Plus switch, okay. Let's see if it's working. Yes, it's working. Let's delete keyframes. Let's go to the first frame and see the top. Plus top, minus minus, top top. Let's see the rotation is working. To front, to backwards. Okay, it's working for the top. Should be work for other buttons here. Let's configure that. Just copy here, apply to bottom. Copy the callback script, the same rotation faces. Change it to bottom. Minus, copy again. Let's go faster here. Okay, now let's see with all the rotations if it's working. Let's delete the keyframes. Let's the inverted angle should be included too. I forgot that. Delete the keyframes. I forgot. Invert angle. Apply. Delete keyframes. Okay. Now let's create some animation here. Top, bottom, front, back, left, back, front, bottom, top, back, right, front, top, front, back, left plus, bottom, top, front, back, left, front, back, bottom. And reverse the animation, go to the first frame and reverse the animation. Let's see if it's working. Pretty cool, it's working. Guys, we created our Rubik Cube with the right resolution options here, reverse animation. Now let's configure that right now to make the animation of the explosion and the splashes. Let's save the node. Now let's see how I created this room for the explosion, debris and the splashes. First, I created the box with these dimensions here, 0.8 in Y, uniform scale 20, axis divisions 2x2. Match the size to align the bottom. Set the same color face, that's the script, from the Rubik Cube. Create a new node here. Because we are going to position our camera in the red face, we need to remove this red face here. Create the name of the room, mesh. We need to reverse some normals. Create unique points. And promote the attribute color to primitive 2 points. Now let's see how I created this. The animation from the cube, the lift off, and the explosion debris. Let's see the network. First, I just imported the animation of the cube with the high resolution active. I transform it to align with the ground. I use a time warp to make the animation faster. I animate the lift in 30 frames, just a lift, and start off the scramble. Another lift shake here. When the cube is finished the solve, there's a shake animation here using a shops. Shop is controlling the X and Y rotations of the cube. That's the result of the shops. For example, if you want to create the shake here, you just need to left click the channel. You will need to create the animation, motion effects, noise, and you apply the noise to that channel. Then I apply the noise to X and Y to make that shake after the finish of the solve. Create a checkpoint here. I freeze the frame 110. I delete the attribute name I promote the piece ID because I need this attribute for the fracture. I create a VFX attribute here as name equals piece by piece ID to store a new attribute name. And I delete all the attributes except the CD and name. Here, I just delete the name and fracture the Rubiks. Just the full parameters here. If you want to see the exploded view, that's the result of the fracture. Then I create the velocity point. I extract the centroid from the cubes. I create the oriented attribute. And I create a VFX here just to calculate the velocity. The velocity should be from the center of this point here towards the direction of the piece. If you want to see the velocity result, you can see here. That's the velocity, what is super big. That's the direction of all the velocity. I use RBD configuring. After that, I create RBD constraint properties. We don't need a high strength for the constraints. And I cache that, just one frame. That's the static frame for the simulation. I create RBD pack and RBD unpack to enforce unique name attributes per instance, because here there's a lot of pieces with the same name. Then I need to create, for example, these three, the face white, red and green and red pertains to the black structure here. After we enforce the unique name attributes per piece, all this piece should be a different name from the inner structure here. The collider is actually the room, which is created here. For create the collider, we import the room, make a bound, reverse the normals, unique points with using facet, scale the primitive, poly extrude a little bit, and using collision source. Now back to the debris. Here, using the RBD bullet solver. Inside the bullet solver, have just a pop spin to make the particles, the debris rotations after the explosion. With the simple script here, spin speed variance by 306 to 1080. Some pieces rotation is slow, another pieces rotation much faster. And I cache just the points for the simulation. I don't need all the points. Let's see. Yes. We cache just the points because we don't need to cache all the geometry, just the transforming points. Let's see the result. That's the result of the point simulation. And using transform piece, we can apply back to the original geometry the simulation. Like this. For that, you create a transform piece. Using a time shift here to freeze the first frame of the animation, that should be 110. After the transform piece, we create the unpack, compute velocity for each primitive, for each geometry. And here, we create a switch for the normal formation at the beginning, normal scramble. The shake for the final result, and the frame 110, we switch that animation procedural to the simulation of the exploding debris. After that, we create an attribute delete just to keep the attributes we need the color and the velocity for the shader, the rendering. And we split the inner structure, let's see the background light, the inner structure and the face colors, and merge back and delete all the groups. We don't need any groups for the rendering. Now we are going to see how I create the splashes for the Rubik's explosions. That's the result of the splashes. Let's see the network and see what is happening here. We already created the collider, which is using the side that debris explosions. For the splashes, we import the cube, freeze at the first frame, the 100, create a bound for that, create a sphere align with the bound, apply a mountain modifier here, a mountain noise, and create the flip source. This flip source is composed of the surface and the points, the particles. I create a noise here just to remove some points we don't need, just to make the variation, like a noise variation here. If, for example, want to remove the more points, we can adjust the ramp here, like your desire. I just keep the face colors here to transfer the colors of the face colors to the points, the particle points itself. And I creating using VFX here like 6 groups, 1 group for each color. And I don't need the white color at the top, then I remove that. I create a velocity for each color based on the position of the face. For example, the position green should be just that position here, that direction of explosion. For the blue, for the white is bottom. The red, for example, is that side here. And the origin is the other side. Let's enable all the velocity again. I create an attribute called viscosity. And I create a flippy source. The flip source is compound of the flip solver, a flip object. I imported here the collider using static object. Point to the collider node here. I use the vellum source. The vellum source should be the first input here, which should be that particles. And I create a VFX script here just to make the particles which colliders with the walls just to stop and don't slide the walls. Just fix the position and stay at the wall. And a gravity here. After the solver, before the cache, I delete all the attributes we don't need, but I keep the ID and the CD. I delete all the groups, we don't need any groups for the rendering. And I cache the particles. That's the result just for the particles. It's pretty fast. You can see, for example, here, the particles that collide with the wall don't slide down, just stay fixed at the walls. Then I convert that to particle fluid surface to cache geometry. But when you create the particle fluid surface from the particles, we don't retain the colors. We need to grab the colors from the particles and transfer back to the geometry here. And transform the velocity too. We need the velocity. Compute velocity for the particles here. And transform the velocity and colors for shading and look dev. I use a time offset here, time shift, just to start the same position when the cubes finish the solver, which is frame 110, start the explosion. I smooth the color a little bit, because for example, after the color transfer, you can see a sharp blend here, which is not so cool. Then I use the smooth colors just to blend all the colors and make a more interesting shape. And I created the name just to reference in the Solaris and apply the shaders. Now it's time to rendering. I create a loop network here, rename it to Rubik Cube. Let's dive inside. First, I import all the geometry, the room, the cube itself, and the splashes. The room is just a simple room here. Just grab the path and use the sublayer style copy sublayer. The cube animation from the beginning scramble until the debris explosion. And the splashes. I merge all together, create a render geometry settings here, using type mesh, and activate the motion blur here. I import the camera that I created in SOPs, in object level. Let's disable this guys here, this error. That's the camera view. Let's see the material. I create a material library and I create 4 materials here. For the room, I just create a particle attribute lookup and use display color. And I create an animation here. Let's see in the rendering. Here, for example, at the start of the animation, the walls is just a pretty pure white. When I start the explosion here, you can see a blend animation. Start here, blend a mix animation from the white to the wall colors. I use, I think, frame 110 to 140. A LERP animation here. Inside the shaders, yes, I use the expression here to animate the blend colors from white to the colors. From frame 117 to 125. The splashes is just a simple shader using display color applied to base color with the roughness 0. Cube body, just a dark color here. And cube face colors use the same particle attribute lookup with display color, with some little roughness here, 0.2 in roughness and a cold to reflection, 0.2 in the weight. I use a frontal area light here, that's the bigger area light, and using some studio light here, a dome light. That's the file. Let's see the file. What is this? That's the studio light file. It's just a free image from the internet. And let's see the result of the rendering just for sample frames. Let's see the result of that frame. That's the result of the frame forming, the scramble. Let's see the frame in explosion. That's the result of this frame. that's the result of the render, guys. You can download for free this project at Gumroad. You can explore how I create the cube, follow the tutorial, and understand how I create the splashes and the debris animations. Thank you guys, see you at my next video.